Welcome to Volume 1 Dust Interaction, the ultimate tutorial for creating stunning pyro simulations. In this lesson, we'll start by creating pyro source and learn how to apply useful technique to create dust and smoke simulations. We will understand Voxel workflow and create Sparse Pyro Solver from scratch. Along the way, we will learn how to apply microsolvers and control their value. And we will study velocity as well and explore other smaller tips and tricks to enhance your simulation and find the perfect voxel size for your scene. We will even learn how to create moving object smoke simulation in Pyro Solver SOP. Once we get decent sim result, we will import our result into Solaris and render it using Karma XPU. And we will check out MaterialX and learn how to render it faster. So check out this exciting new course where we will explore the art of creating stunning dust simulations from basics to advanced techniques. So without further ado, let's get started. So let's talk about learning approach. So how to learn Houdini. So in initial stage, focus on basic. What I mean by basic, node workflow, designing source, go one by one. In this tutorial, you will find some advanced technique and complex technique as well, which is a bit difficult to understand. So if it's too difficult, then you can just take a screenshot of it. Just remember that where to apply it and don't try to remember the wax and everything. You can just easily take a screenshot and save. And always keep a library of smaller things. And as this is volume 1, so I will cover few useful parameters to create this cool dust simulation. Right, so one more last technique before starting this. Houdini is very vast. Some things is quite complex and something is very easy to understand, So try to mastery in easiest things. You can just level up over the time. So let's start with setup next. So let's start by saving this file. And if I go to this file, I have an options create new projects. So what it will do, it will create these folders and everything. So in my case, I don't want all these folders, right? So I'll just save this file directly. And here I'll just go and on desktop, I'll create this master folder. And let me set file name. You have to keep it short. Volume 1 Dust Interaction version 1. Save this. And if I go over here that I have some $heap, $job and $temp as well. So what are these? So these are variables. We will learn more about this later. And this is viewport and these are the network view and here the parameter. And this looks cool, but if I create anything, how do I understand scale of the scene, right? So for that, I prefer using this test geometry and there are a bunch of test geometry and use this Tommy. So this is actual human scale and Houdini works in meters. And if I just check these, middle click these 1.78 meters. We have to imagine us standing there, right? And we can just compare things over here. And I want animated geometry as well. And for that, I will use this crack. So which is walking around over here, right? And this angle looks cool. To create camera, I can just go over here and I can just click over here. It will create this camera. And I don't want rotation in this axis. Yep, this looks cool. And I want 120 frames only. Cool, so let's just set these for scale. And give it some cool color. And also do set hotkeys and I have provided link for that. Next, let's learn about voxels. So basically, voxels define quality of volume pyro and for image, it is pixel. So here I have this simple example to just check. And if I increase these pixels, you can see here there's image is getting more clear. right? So this is more clear now, and let me just use 300. Yep, this looks good. So here pixel define the quality of image. So similar, voxel define the quality of pyro volume. But main point here, we need to understand how to define voxel, pixel over here, right? So this depends on distance as well. And if I just reduce this pixel, and if I check this, if it was in this distance, it's totally fine. We don't really need that 300 pixels, and here we can even optimize this, and there is too much distance like this and totally fine, right? And if I go more closer over here, and I need to increase this. So why I'm talking about this distance, the same concept applies in voxel as well. So this was the example of pixels, and let's just check out voxels as well. So voxel is also like 3D basically, and you can see here this is voxel size, and if I reduce this, and don't worry, I will talk about this in some time, but for now let's just visualize this. If I reduce this, you can see here that we are getting proper shapes over here. Void 0, let's use 0.1, right? So if I reduce this more, the more cube it will add, and it will define more clear shape. And let me just reduce this. Yep, this looks awesome and proper shape it's taking, right? Check out this, we have clean edge, right? So but if I increase this, you can see here that we have some voxels. Along the way, we will learn how to choose correct voxel size. We won't waste any voxel, and based on distance only we will figure out how to choose correct voxel, right? So these are the similarities in pixel and voxel, right? And now let's understand this in more depth. If I middle click over here, that I have this point, primitive and peg geometry, right? So I don't want this hammer, so let me, as it's pegged, so I will just unpeg it, right? So it's unpegged, so I have proper numbers of primitive, vertices and polygons. So this is geometry, and how do I convert this into a volume? So for that we have these two options. So one is Houdini's default volumes. You can see here it's not clearly visible, so let me press D, and for while working with volumes I prefer using dark background, and I will keep this as a default only. So save as default, it will be saved, and now you can see here it's clearly visible, right? So as I have mentioned, this is Houdini's default volume. So if I middle click that, I can see some voxels, voxel size and its volume. The name is not defined yet, but here I can just type this name. For volumes, we will work on this density. And now if I middle click that, I have this name. And how do I increase the quality of this volume? So for that I have to increase this. And yep, let me increase this 100. And let me use 200. As you can see, it's taking time and we don't have very clean volume as well. So the good thing is we have other options as well. So as this was Houdini's default, so other option is VDB. So here if I go that, I have that option VDB from particles, VDB from polygons. As these are polygons, so we will use VDB from polygons. And let me check this, connect this. So it gives two options, distance VDB and fog VDB. So this distance VDB, we will talk about this later, but for information, we will use this for collision. And here I'm interested using in fog VDB. And let me just reduce these voxels. You can see here, this is really quick and we have more better over here. So as you can see, VDB is more faster, right? So for source, we will use VDB only. And next we will talk about Pyro source. Let's understand Pyro source workflow. Let's take a box and it's a polygon. So here we have Pyro source node. So what it will do? It will scatter some points and it will create density attributes. It can be anything. It can be a temperature, fuel, burn. And this is not the only way of doing this. We can even use points from volume to scatter points. And we can use point angle to add attribute. And till here, they are just points. and we have to convert this into density. So for that we have one more node, volume rasterize attributes. Basically it will convert points into volume. In previous video we have used VDB from polygons, so that was quick way of generating any volumes, and here we are scattering particles, creating attribute, after that we are rasterizing. The reason of doing this with points, we have more control. In some cases VDB from polygon can be worked, but in most cases this is more procedural approach. So end goal is creating a volume. It can be any approach to do that, right? So now let's create this. Cool, let's delete this. And here we will use simple geometry like box for testing purpose. And let me use Pyro source over here. If I connect this, it will show some points. And these are the cube points. Here if I increase this, and you can see here it's a point of cube, because we have this keep input points mode on over here. And I have other options as well. I can use surface scatter, so it will just scatter on the surface only, but I want to scatter inside as well, so for that I will use volume scatter. And next I have particle separation. It will scatter particles based on distance. So if I reduce this, we will have lesser distance and more particles. And after that we have particle scale as well. So if I go over here, middle click, and you can see here we have P scale. And how to visualize this? For that, let me reset this. And to visualize this, I can use copy to points. And here I can use box to copy this on each point. So I can see here it's properly distributed. And this is the scale. So if I reduce this till 1, right, so it looks like box, but it's not. And if I reduce it by 0.9, you can see here distributed equally. And if I reduce this particle separation, you can see here, this is cool, right? And now if I visualize this, I have other options as well. So I can just click on this plus icon and I can add attribute over here. So here I will use density attribute, and I have this value as well. And let's visualize this value. So I can just go over here, geometry spreadsheet. I can just see density, p scale. So let me increase this. So these are both linked to each other. And let me keep this default. So now it's time to convert this into a volume. For that, we will use volume rasterize attribute. If I connect these, I have some parameters over here, and I have to just select that attribute. So if I go over here, I can just select this density attribute here. The most useful parameter is voxel size, and we will talk about this. So what is voxel size over here? If I reduce this, it will increase the quality of voxels. And now you can see here, and if I reduce this by 0.5, volume rasterize is copy stamping this each boxes on points, and that's what it's doing. Let me just make this default. So that's how it's generating this volume. But the main question over here is, how do I figure out which voxel size I should choose for this one, right? So if I just view from camera, then I can see it's really in distance. And is this voxel size enough for this one? To figure that out, here we can see that this is the basically a voxel size as well. Now if I visualize this, I can see this is the voxel size if we keep this 1 over here. And if I reduce this, you can see here, we can just understand this as a pixel. Is this pixel enough? No, it won't. So we have to reduce this more, right? So you can see it's really tiny over here, and this is still not enough. We can just even reduce this even more for this distance, right? But if I reduce this to 001, then this is really high. So in most cases, 005 is fine for this distance. But as you can see there, that every time we cannot just place this box over there and visualize this, right? And what if this box is in that direction? So let me just Let me just move this in that direction. Right, so if it's in really distance, then how we can just visualize that? So for that, we can just calculate center of this point, and I can just copy stamp there. And here we can use peg geometry. If I connect this, I will get one single point, and I can just visualize this as well. Right, if I use copy to points over here, it will just place there. And now if I reduce this to 0.1, right, now it's really easy. If I place this anywhere, it will just follow that. So for this distance, this tiny point is fine. And you will understand this more when we actually simulate this. For now, let's just reset this and reset this as well. And next we will talk about top network.
Before exploring DOP network, I wanted to mention that around 80% of the audience watching are not subscribed. In our industry, we have a limited audience and your support means a lot. If my tutorials are helping you, please consider subscribing. It's free for you, but it will motivate me immensely to create more content for you. Additionally, if you'd like to support me further, check out my Houdini files and tutorials through the link in the description. These setups are well optimized and easily modifiable to meet your requirements. Thank you for your support. Now let's continue the tutorial.
Cool, let's organize this one. Let's rename this. Do remember it's generating VDBs, so this is faster. And now let's add DOP network. And we can rename this here as well. And at object level also we will rename this. So here we are creating source and DOP network inside one node only. So now let's double click over here. So we have nothing over here. First we need brain, so which is solver. So let's type sparse. So basically it's a Pyro solver and it's sparse. And let's just check inputs over here. So it has objects, advection, sourcing and forces, right? So we need object to run this. And let me again type this sparse. So I have that smoke object sparse. Right, let me connect this. So it's showing some domain over here, right? And let me just rename this as a dust. Cool. Let's just run this. So it's showing nothing and it's playing real fast. Let me just turn on real time. And this system is ready to simulate anything, right? And here we need to import source. And for that, we will just copy this path. And I will use volume source. And copy this over here. And I can just paste this SOP path. Now let's run this. It still won't play anything. And here we need to just call this density field inside that source. So let's just check how we can do that. So here if I select this and I can scroll down, I have that operations option. And if I click this and I can just mention source volume, and field rank is scalar, and we have two options. Vector is for velocity, which we will talk later, and source volume is density. And target field is also density. And now if I play this, it's playing over here. So Sparse solver understands this density field, right? So if I click over here, it will just take that into the system, right? But if I use density X, it will still run something, right? So as you can see, but it won't visualize or it won't add back or something, right? So it knows flame and temperature and density. And now let's just check out some parameters. So these are SOP mask, DOP mask, so which is to multiply some field. And after that we have source scale, which is, I can just reduce this. So there are a bunch of operations. So this is more like mathematics. And if you want to add or you want to keep it same, subtract and anything. For density, I want to add density. So if we are adding 1, and on next frame it will add one more, so in total it will be 2. But if I keep copy, it will be the same. it won't add in the system. So here I will just reset this, I want to add. And if I select the smoke object, so I have most useful parameter is voxel size. And now it's time to link this. So let me just copy parameter and paste over here. So I will use paste relative references. So the advantage of this, I can just change this over here as well. It will reflect over here. So 0.1 is fine. And second thing, I will use this same parameter to link here as well, particle separation. And I want to use half of this. So let me just divide this with particle scale. Copy and paste over here. I will have enough particles when I reduce voxel size. Cool. And now if I select Pyro Solver, I have time scale and other parameters. So some parameters I won't touch as it's meant for fire, explosions and everything, right? So here I'm interested in using is shape. And here is dissipation. It will control the dissipation of dust. And disturbance, so how this works basically. As you can see, if I play this, it's static. And if I middle click, it has this active and density only. So it's showing two field only. But if I introduce this disturbance, now if I reset this simulation, I will have more, which is pressure and velocity. And let me talk about velocity only. So density cannot move on its own, right? So it needs some position shift. With the help of velocity, it will move around. So here we need to understand this velocity as the extra force, and that velocity will be added in the position of the density, right? That's how it will change position. And here, if I turn on this, it will enable some parameters here as well. And now let me just increase this to visualize this. Yep, there is some moment. Cool, this is interesting. And this is basics of Pyro Solvers, how to build this. To make it work, we just need these three nodes: Pyro Solver, Smoke Object, Volume Source. We will work more on this next. Let's select this, and if I scroll down, I have some field over here. And this is density, and second one is velocity. And if I disable this, it's not showing any velocity over here, right? And if I turn this on, then only it's working on that. And here also we have to mention this block size. And if I go over here, that you can just check. Let me increase this. So block size is 1. So if I keep this 1 over here, then you can see here it's taking the shape of that. This is called microsolvers, and we will talk about more later. But for now, we need to import this outside as well. To import this, we can use top import fields. And I can just select these, click and drag. And here, I need to select the default object, which is dust. Let me just import, and its density. It won't load anything, right? So object is already we have mentioned over here. So we can just keep this blank. And now if I play, it will load something. And if I press, and let me just change this. So you can see it's showing over here. Why I have imported outside? If I add light, so let me just click distance. And I want to change the angle of light. So for that, I can just go over here, look through the light, and let me just check. Camera is over here, and this will be the best view for that. Yep. So as you can see, it's low res, and at the moment, let me just link this over here. Let me just paste this. I don't want to link this. Okay, so the current voxel is this much, and let me just reduce it by point. This is still not enough, but we can, for testing, we can use this. So let's use 0.25. And now let me run this. If I reset this, yep, we have good resolution over here. This is without light and this is with light. So outside we can see impact of light, but if I go inside, so those light won't be useful over here. Let me just disable this velocity. So for better visualization, it's better to visualize this outside over here. And now we can work on source as well. Let me add grid over here. Yep, so it's covering that area. Here I want this intersection point. If I typed intersection, I have intersection analysis. So if I connect these, it will give me that intersection without changing any parameter. And I prefer turning this on, so it will give me proper curve as well. And for safer side, if some point doesn't intersect properly, so just for source, I can just use minus 0.1. So I can just shift a bit. So it's taking time to load, right? So here I can use file cache. And I can save this. So remember I was talking about this $heap. So it's a variable. And if I go to this edit, aliases and variable, if I type this $heap, it will read some path. But which path? To visualize that, I can just go over here and heap will read this, that master folder I have created. So if I cache everything over here and I copy paste this folder anywhere in the drive, it will auto sync this path and it will auto construct this folder and everything. But I don't really want this. So I will just create this cache and I will use $OS. So that's the name of this node. I can just middle click and check. So here I will just use intersection v1. So if I want to just version up later, I can do that. Let me load this and save to disk. Cool, it's showing. Now I will just connect this over here. Will this work? Let's just check that out. It's not working because we don't have volume to scatter. And I want to have some mesh around this. And for that I can use polywire. So it will create radius around it. And it's too high. Let me reduce this more. It's too thin, so I can just increase this by 25. Yep, this is fine. And let me just merge. To visualize this, do I need to increase? Yep, this was fine. It shouldn't be visible. And as you can see, I can see some hard cut. And for that, I can just increase these. Yep, this is good enough. Now if I connect this and check, yep, this is working. And this is also working. Cool. Let's visualize first simulation. Connect these, go over here and run this. Let's make a first flipbook of this lesson. Yep, that interaction is working and we will enhance this more next.
Now let's discuss velocity, which is very important for the simulation.
Here we need ground collision, but before adding that, let's organize scene. I don't want to connect this way, right? So I'll just delete this and I will just copy this over here. One more node to input there. Cool, that's it. And let's just talk about what we learned till here. And so this is the geometry scale we have. After that we are scattering some particles on it, and we have attribute as well, and this is converting that into a volume. After that we are using this as a source, and here we are just using this object source and brain over here, and after that we are calling everything over here. So let's just name this import dust, and here's the default object, which is this one. Yep. So if I zoom in and visualize this over here, I need ground collision, and for that I can quickly use this ground collision. And if I use merge over here, it has that left input affect right input, right? So I have to merge this first, and after that I can use this merge. So let's just reset the simulation. It's working. If I go outside and just cross check, yep, it's working. But for this kind of flat surface we can even use simple approach. So here if we select this, we have some max size and boundary conditions as well. So what max size and everything, let me take a screenshot. So in old school Pyro solver, we have to define the boundary where we need to simulate. So in that boundary we have option that we need to collide with this boundary. But with Sparse solver, it's very smart. So wherever there is a source, it will start emitting without defining domain for this one. So here also we can, without defining this domain, we can mention that we need to close below y-axis. Yeah, so as you can see, it's very fast, and if I reset the simulation, it will take lesser time. And one more tip I wanted to give you. So as you can see, this is really close to the grid, right? So if it's not close to the grid, right, so it is somewhere here in the axis. Will it still simulate? The answer is no. It's not simulating. So why? Do we need to define domain for this as well? Nope. So if I select this, I have one option, enlarge fields to content sources. So as you can see, it's emitting something over here. Now if I reset the simulation over here, it will simulate that. Sometimes it's not close to the grid, it won't simulate if you don't turn on this option. Cool. And now I want to disable this disturbance. Yep, let's just check this now. And we can delete this transform. So now what we need over here is inheritance of the character. An object in motion stays in motion. So for that, let's talk about velocity. Yep, so I have this sphere moving around, right, in 3 axes. So velocity is vector value. So it has 3 values, x, y, z. I want to calculate speed, which is single value, meaning it's a float. So I need magnitude of vectors. On paper, I have to calculate vector speed is equal to square root of axis x, y, z. So for now, let's take 111 axis. It will look something like this. So if we combine all of them and we find a square root value of that, this is the actual speed if we use this 111. So that's maths behind it. So Houdini smart calculator, we can easily use length function and get that speed value, and even we can link that value to any color we want. So here let's just add some color as well. Most trickiest part in like simulation is when it stop moving, it should stop emitting as well, right? So where we can use this maths. So let's implement this in Houdini. So I need velocity, so let's calculate velocity of character. We can just put trail over here, compute velocity, and if I middle click over here, it's not there, so I need to attribute transfer that. So it's there, right? So let's just visualize how it looks. So if I go over here, it's not there, right? So if I want to view that velocity, I can just go over here and click V, and let me just check. Now I have that option. Yep, it's working. And here also, this is how velocity looks like. And if there is anything wrong, you can just cross check over here. We can see something in viewport. It's not actually there. We need to reset the viewport. It's removed. Cool. Let's just reduce this. I want to set some limit over here. So I'll just transfer in this distance threshold only. And now save this. Cool, we have it over here as well. But if I select this, I don't have it over here anymore. So Pyro source doesn't transfer that velocity. But if I use V and even select this velocity also, it won't take that value. So it's better we use this attribute transfer again to get that velocity in here as well. Set the radius to 1. Yep, it is there now. So simply we can write V over here and it will add that velocity field. If I middle click, you can see it's velocity field, right? So but if I go like high resolution, right? So if I middle click, just check how much voxel it's consuming over here. And at the moment it's 9 MB. So if I remove this velocity only, you can see velocity is taking 6 MB, and this is just really small source. Just think about the what if you are working with large scale, right? So in that case it won't be helpful. So it's always better to use this separately. And here we will have fixed voxel. Maybe we can just use 0.5. That's the value. Let's just check how 0.5 looks. Yep, for velocity it's fine. We don't need that extreme resolution in here. And now we can merge this. Yep, it's working well. At the moment it's too high resolution. Let's just reduce that. Yep, and one more thing, as you can see it's stopped over here, right? So I don't want to emit smoke over here. So for that, let's just make some room, as we will add some extra nodes over here. So for that I was talking about the length, right? So let's use that. So we will use point triangle. Right, so here if I middle click, I have that density attribute. So let's take advantage of that. We can manipulate density attribute over here. If I just type density, 0. Yep, it's working. So what I need over here is I want to link this to velocity. So let's type at speed equals at v. So at the moment this is vector, so we need to check the value of this, what's happening over here. So we can just go to geometry spreadsheet, and here I can just check the speed, right? So we are getting some speed. So this is vector value first, so we need to convert this into a magnitude, right? So let's type length of velocity. Yep, so this will give me some value. And if I go over here, yep, it's working. Let me visualize this. Is it working? So we are getting very low value over here. This is quite high value, but still, yeah. On this frame, as you can see, it's going above 1.4, right? Let's just visualize this over here. So to visualize this, we can just use CD, and let's just set that value at speed. It's 0, 0. Yeah. So as you can see, if it's moving, it's okay. I need some value here as well, so it's easy to visualize this. So when it's yellow, it will emit, otherwise it won't emit. So that's what it's doing. And here, as you can see, some of those values are going above 1, so we need to feed that value. So we can just simply type feed 0, 1. So it will just stay between that value, it won't cross that over here. Can you see? Cool. So I think now it's time to multiply that with density. So whatever above value we are getting, we need to multiply that with speed. Cool. So now if I check, yep, that's exactly what we want. So now let's just check. So after adding velocity also, it's not working. So we have added velocity over here. So as you can see, it's still density, right? So we need to change the name of this V over here. And if I middle click, now we have that velocity. Let's reset the simulation. Still it won't read that by default. Now let's dive inside. We have to make sure that we need to read that velocity over here. So if I type V and V and it's a vector, will it work? Still it won't work. Pyro Solver doesn't understand V. So what it understands is well. So we have to make sure we properly type these things over here. And now if I check this, reset this, awesome, that's working. So an object in motion stays in motion. Cool. So we have some operations as well. We can subtract, multiply. So you can always explore these things, what it's doing. You can just use extreme number over here as well. right? So these things are useful in some cases, but in this case we can use add only because we want to add velocity per frame. Yeah, so I will recommend to test all this operation for better understanding, but for now that's fine. Let's just go with one scale and let's make a flip book. Let's play this. Yep, this looks cool, and we will add some microsolvers next.
Before exploring microsolvers, I wanted to mention that around 80% of the audience watching are not subscribed. In our industry, we have a limited audience, and your support means a lot. If my tutorials are helping you, please consider subscribing. It's free for you, but it will motivate me immensely to create more content for you. Additionally, if you'd like to support me further, check out my Houdini files and tutorials through the link in the description. These setups are well optimized and easily modifiable to meet your requirements. Thank you for your support. Now let's continue the tutorial.
Initially I was showing microsolver, so this is the right time to talk. So it's good to add microsolver after adding velocity in the system. But as you can see, the current velocity looks quite boring. We can modify these before adding any microsolvers in here. So as you can see, we can visualize this velocity over here. So do we have any option to visualize that at SOP level as well? So let me just go over here and check velocity. So we cannot visualize this way. So there is a different approach for that one. So for that we will use volume trail. So first input needs point, second input needs that volume velocity. So here we can just use scatter. We can just scatter some points and connect this for you. As you can see, this looks very straight and I want to modify this. So for that we can use volume velocity and I can just connect this. So to add noise, we can just go to curl noise tab and let me add. Yep, so it's adding. So here I can just make some changes. So let's just use 0.25. So is this noise fine? Yep, it's fine. And in fact, we can increase this grain as well. 0.75. Yep. And let's increase scale as well. So as you can see, this is how it looks right now. Let me reset this simulation after adding volume velocity. Noise. Yep, there are some breakups. And there is too much force at the moment. It won't inherit that much. So we need to reduce that. So let's just reduce by 0.1. 0.1. So let's just, and before making flipbook, let's visualize this in more better way. So let's use, to visualize this, let's use bake volume, and we can connect this. So if I check this, I can just increase, let's just use 100 and change the color of it. Yep. And this is one way of visualizing, and there is another way also. You can use volume visualizer. So here also it's quite easy that we can just go here and mention the field, and after that we can use infrared. So if there is a high density, it will show different color. If there is a low density, it will show different color. Cool. Let's just visualize this now, make a flipbook. Yep, this looks cool. We can enhance this by adding microsolvers. So let me just pin this over here and let me just quickly introduce. And current block size is 0.2. So is it working? So if I check 0.2, yep, it will work. That's fine. So for this scale, 0.2 is quite better. And yep, let's just make a flipbook. Let's reset the simulation and check the difference. Yep, we can see some difference. Make a flipbook. Yeah, this doesn't look right. So what's happening over here? So disturbance is working, but it's continuously adding noise till the end. So we don't want that. So as I have discussed then, it's a good idea to add microsolver after adding velocity. So if I just disable that and if I check inheritance value over here, so as you can see, there is force when it emits and after that it just slows down. Based on that we can add disturbance. And yes, I'm talking about the length only that we have discussed. That's why I was talking about in that depth. So how we can use that over here? Do we need to use wrangle to length? So the answer is no. Pyro Solver Sparse is quite smart. So if I go to the simulation tab, I have that calculate speed field. So what it will do? It will just give same simulation, but it will add one more field which is speed, and we can use this field to drive that disturbance. And how we can control the disturbance? If I go to shape and I have that option control, and here I can mention speed, and I have to give control range as well, so minimum and maximum over here. So here I don't want to put any random value, that so we won't have same speed object every time, right? So we need accurate value with proper visualization. We should be able to visualize that, right? So here there are multiple ways to visualize that. So one way is this, that here we can just input that to speed and I can just load over here, and this is the range. So this is value 1 and this is value 0. So I want to set cutoff till 5, right? So it will add that disturbance on red value only. So at the moment red value looks lesser, so maybe we can just reduce this value. Let's go till 0.8. So I need little bit only, so I can just break this shape over here. Let me just use that 0.5 and 0.8. Let's just reset the simulation. As you can see, there is a minor difference. That's what actually we want. And let's visualize this now. Cool, it's working quite good. And one more tip, you can use this multi-field as well for visualization. It's similar like volume visualizer if you don't want to use that way. And one more thing, so this simulation looks cool, but there is something wrong. So if we follow the real physics, there is always atmospheric drag. So there will be like impact and simulation should slow down over time. So here also we need that similar behavior. So we need atmospheric drag. So let's just find out drag. So we have some drag force, but so those are for particles or RBD. But here, if you want to apply this over pyro, we can use dem. And where we need to connect this, we can connect this in the forces. Let me just use merge and I can just connect this. So let's just leave this default value and check. So always just check default value and you can just go extreme. Let's try both value. Yep, it's working. Let's just check extreme. How is it working? It's giving some weird result over here. Let's just check one value only. Yeah. So as you can see, extreme value is not working. So good range is 1. Yep, it's working. So I think we don't need that. Maybe 0.01. So this is always depend on which reference you are following, right? So always follow some reference. For now, I'll just go with this value. I think that's fine. Cool. So now we have drag. And after that, let's add wind as well. So we need large noise for that. And if I select these, let me just increase size. Maybe I want this large wind. So let's just use turbulent for that one. So I can just go here, simply use gas turbulent, and I want that large swirl size. Cool. Let's just check what we are getting over here. Let's reset the simulation. Yep, it's working, but it's too much. I have to reduce this. Maybe 0.01, or let's go with 0.02. We did need that less value. So as you can see, wind is working. But what's happening over here? If I go to just this tab and visualize that, it's changing noise pattern, means it has some animation also. So if I go to this pulse length, so it has some noise, animated noise, right? So we need less animated noise. So to slow down, we can just increase this. Let's just check this now. So it won't be visualized this way, but we have reduced it. Can you see? It will stay in the one direction only. So if we don't use that, by this frame, it will change the direction. Let me reset the simulation. Yeah, it's changing its path a lot. So it should move slower, means the noise over it, and we can just overall reduce the scale as well. So this will be really minor effect, but it will work as a wind overall. So that's fine. Cool. Let's just simulate this. Everything looks cool, but I don't want this in the simulation. So how we can break this edge over here? So first we can play around this with the speed and everything, but we don't have to depend on speed. We have other controls as well. So such as we can just check out density. So which frame was that? It's 79. Let's go to 79. Okay, so just check this. Let me reduce this. I want to cover more area. Yep. So this range is fine. So here we can introduce one more disturbance with same block size, and I want to use density over here, and we have defined the zero point 0.4 and 0.7. This will be the range. So let's leave everything default and just reset the simulation. Okay, so there is no effect. We need to increase this, double the amount. So after trying everything, we are not able to find the solution. So that's hidden over here, threshold range. So this is the minimum range. And if we check over here, so this is the minimum range it has over here. So we need to disable that range in order to add that. So here we can just keep everything default, and if I just show you this real quick, it will apply that. Right now you can see we are getting that noise over here. That's what we want, and we don't want that much. Let's just reduce to 60. And in fact, now let's just reduce the voxel size for better quality, and let's just quickly check that.
Now let's tweak the simulation and add collisions.
Let's play these. So as you can see, it's working, but we see some issue over here. And what's the issue? Let's just go here, and after adding currently I'm visualizing this. Let's just visualize this for a moment. So if I check this, I have velocity in all the frame, right? So similar treatment I have to apply with velocity as well. So we need to mask velocity, right? And one more thing, if we add velocity over here, so till here it's a 0 value. Let me just cross check. If I go to this frame, right, so you can see here to select velocity to properly visualize that. Till here it's 0 value, but when we add volume velocity, we have some noise all over, and we don't need that. So here also we need to mask that. So if you check that we don't have density, wherever there is a density, we need velocity. We can use mask over here. So first mask, we can just write this at SOP mask density. It will fix that issue. Let me just show you that. Right? But we are not able to clearly visualize that what's happening over here. So to visualize that over here, we can just use volume wrangle, and we can do that treatment at SOP level. So we will just type V multiply by density. So if there is any high density in some areas or something, it will add that as well. Right? So now it's easy to visualize and everything's working well. Cool. Let's just check this and now make a flipbook. Let's check this. Yep, it's working. So one more thing I want to add is can see it's adding lots of density in the scene, and we don't need that much, and we need even some breakups as well. So if I select any of this frame and if I go to that, can you see it's covering entire area? So maybe we can add some breakups. So for that I can just simply use warp. So we can use warp, volume warp, to add breakups in the density. So let's dive inside, and you can use turbulent over here, and it needs position, and we can check what's this output. So it's not visible over here, so we need to multiply this output with our actual density, this density, and just visualize this. So something is visualized over here. So current value is not from 0 to 1, so we have to make sure it's 0 to 1. So let's just feed this. So in most cases 0.3 works the best, and let's just change the frequency over here. Let's just, yeah, we need more smaller noise. This is working. We need some minimum value as well over here, so let's just use 0.1. Can you see we have nice breakups, and this will add huge impact in the simulation. And in fact I want to save this over here so we can just compare the difference, how small changes can add drastic effect. Yep, so this is old one, let's play this, and this is the new one. Can you see the difference? We have less density and we have really nice breakups in motion as well. So why it's affecting the motion? Because it's multiplying with velocity as well. So velocity is multiplying with disturbance. So everything is connected to each other. So if there is any change in density, it will affect velocity. And if it affects the velocity, it will affect the disturbance as well. Cool. And we need, let's add more noise in here, right? So let's just go to that frame, and at the moment I was just adding this disturbance and everything, right? So we can use rotational force as well. So what is that? Let's just check. So what is rotational? It won't change the shape a lot, but instead it will just add some detailing. So maybe I can just use half of this one, and it won't be that continuous. So let's just check one. Let me just reset the simulation. Yep, you can see that we have some minor details. Can you see? That's what it's doing, and it's not that continuous over here. Yep, and I don't want that much, so 20 is better, so leave it default. Yep, everything looks cool, and I want to, so as you can see it's dissipating really quick, right? So I want to reduce the dissipation as well overall, so maybe use 0.25, so it will hold those frames. And one more thing I want to show, as you can see we have lots of detail in the simulation, that having lots of details in the simulation is also issue. And I want to give one interesting tip as well. So dust and smoke doesn't stays the same details over the time, it diffuse in environment, and we need to show that blur, right? It should blur over time, and we have that option. So if I just type gas blur, we can add that for more realism. And let me just reset this simulation. Yeah, so currently it's working on all those fields, right? So I have to clearly mention you need to work on density, and this is too extreme value. Let's go really less value over here, and let's reset the simulation. Yep, there is some difference. Cool. I think we can increase it 8 times. And currently we have 0.01. Let me just check if it's this. This is good resolution for viewport, but it's not good for rendering. For rendering, we have to reduce. We can stay between like this value 00. So this will be the rendering resolution. And this is too extreme also. See, it's up to you that you can go this extreme, or I would prefer this. So as you can see, there is not that much difference, but it will increase the simulation time a lot. So maybe we can just go with 0.005. So if 0.005 doesn't give that cool like breakups and detailing in the simulation, so minimum will be like 0.002. Don't go below this value. So that's what we know. Okay, so for rendering we will keep that one, but for less high res viewport we can just use this 0.01. Okay, so let's just check. Let's check this. Awesome. So everything is working really well over here. And next we will add character collision, and it should inherit also, right? So we will work on that one. Cool. Before adding collision, I want to increase density. So if I just check, I have lesser density over here, and currently it's loading speed, so I don't want speed over here. And I can use velocity for motion blur later, so I want to keep it invisible. So as you can see, this is a bit less and it's not clearly visible. I can use these, but that's not helping a lot. So here I have to increase simulation density. So let's just check. So if I increase this by 10 times, it will affect everything from velocity to disturbance. And let's just check, right? Now we have more coverage. That's what we want. Cool. So now let's add collision. Easiest way to add collision is using static object. So here you can just connect and it's easy. But while dealing with volume, there is a smart VDB approach is also there. And let me just show you that. So for that, we have to convert this object into VDB. So let's use VDB from polygons. Let me just hide this. And we can link this parameter with here voxel size as well. But we don't want to link that. Here decent voxel size is also fine, but if we just even increase this simulation voxel, then we don't require this kind of detailing. It's better to keep this independent, right? So we don't need that high quality voxels over here. And we will need velocity also of character, right? So it should inherit with the leg. So for that we can just go over here and click, and here we can mention well, right? But here I don't have any option to select the areas and everything. If I want to expand it outwards, I cannot do that, right? So it's better to use separate in here as well. So I can just use rasterize attributes, and I can just connect this over here, and I can just type v. Yeah, so as you can see, it's working. And I have to reduce this particle scale, and I want to check how much coverage is it covering, and I can just select volume slice over here and check. Let me just give this template, and that's too much, right? So let me just reduce this, and I want to reduce voxel size. That's too much, so I think 0.25 will work. Cool. And here also we can just use volume trail to visualize that. This and here. Right, so here you can just visualize this, increase the radius. Cool. So for now 0.05 is fine. And if I merge, and one more tip, so if you connect this way, then always use well over here, so it's clearly read that field. Nice. And after that, 1 2, as you can see, it's taking a bit time to load, right? So I can just quickly save this character vdb version 1, save it. Let's copy this. And how do I import that over here? So here also I can just use same volume source as it's a vdb. So I'll just use volume source, and if I just check, I have option collision, so I'll just select that. It will fill up some names over here. So first is collision, and it's using -1, and after that it's using this velocity. And let's just connect this. Will this work? It won't work. Why? Because if I middle click, I have surface over here, and this is sign distance field, right? So I have to use this as a minus, and here I have to use mention. And where do I connect this? That's the most difficult question, and let me just show you why. So as it's a volume source, so definitely I'll just connect this over here, and let me increase this voxel for quick simulation. Yeah, and I want to hide velocity. I want to keep density only. Yep, let me reset. Is it properly reading the collision? We have to always cross check that once. So we can visualize the collision part as well. So I can just select this over here. I can turn on collision. And as you can see, nothing is visible in the viewport. So why is that? So collision is not meant to use over here. So it's force actually. The moment I connect this, it's visible. And this is how it looks. You can see here. Now it's reading this as a collision. Let me reset. Yep, there is some collision. And it's reading that 1.5 velocity as well. So let's just check the output. Let's make a flipbook. Let's play these. Yep, it's working, as you can see here in this area. Yep, it's working, but it's too much at the moment, so maybe we can just reduce it a bit. Let's keep it 1 only, and I want to increase this as well. Yep, so as you can see, there is some noise we have, and that's looking good. So which noise is it? So after working with lots of parameter and lots of microsolvers, right? So it's always difficult to identify which parameter is affecting this. So in that case, just select everything. So this is the debugging that I want to teach you. So I can just select this and disable everything, and let me just reset the simulation. As you can see, this is not that disturbance. If I disable this, and let me just check, is it affecting over here? Yeah, it's affecting really minorly. So first I need to get this better. Let me just disable this. Yeah, so it's affecting that, right? And here we can just one more just cross check the speed as well. So as I have already disabled the speed, so I will visualize that over here. Let me go to multi-field and I want to read. Yep. And turn this off. So current range over here is 0.5 to 0.8. That's really less. And I want to cover more area, so I will just reduce this 0.5 and you will just skip 0.5. Yep. This is cool. 0.2 and 0.5. Yeah. Just go outside. So these are the technique we need to control. You know that most of the time what we make mistake, we just keep everything turned on and we keep making these changes. So if all parameters are visible, then it's hard to find out which parameter is affecting that. Yep, cool. So let me just reset this. Nice. And now I can turn on this one. This one is wind. And this is one more disturbance. Let me just test this one. So till here it's fine. The moment I turn this on, I will have different output. Yeah, this is the force we can control. This gas disturbance is adding lots of force in it, and after increasing density we have to control this as well. So let me just type density over here, and current range is 0.4 to 0.7, 0.4 to 0.7. So maybe we can just go to 0.5 and keep 125. That's too less, so I think 0.6. Yeah, 0.5. Yep, that's cool. So we will use 0.5 and 1. Keep everything same. Let me just reset these. Interesting. So now this looks a bit sharp, right? So I want to break this edge as well. So let me just go ahead and turn on this disturbance. Gas fill is also fine. Collision is also fine. Let's reset this. Yeah. So this disturbance is breaking that edge. That's what I want. Nice. Yep. So everything looks cool, and I can increase voxel a little bit. Let's just check. And one more thing, we are feeding in VDB density, but Pyro Solver runs over Houdini default volume. So we have to convert this into VDB now. So I can use Pyro post process, select and convert VDB, combine, convert this, curl, resample. So what are these parameters doing here? So this is for like velocity optimization. So as you can see that if I middle click over here, you can see that density is 0.008 and velocity is 0.05. So here, if I middle click, and let me just use two post process without turning this on off. Okay. So if middle click, I can see here that again it's 0.01 and 0.01 only. But if I turn this on, it will just double the amount over here. It will optimize this velocity. That's what we want. So let's just use and make a flipbook. Cool, let's play this. Oops, so there is really less velocity over here. So I will have to, yeah, so I would like to increase this by 4 and let's keep this 75. Okay. So now I don't want to simulate this entire frame rate, so I'll just keep really less, somewhere around just 40 frames only. Let's play this. Yep, it's cool now. It's fixed. And I want to select render resolution also. Just press. So at the moment we are using these. So 0.005 resolution will be great for rendering. So let me just use this. Dust sim version 1, and we have density, velocity, which is good thing, and we can cache it. Next, let's explore Pyro Solver SOP before rendering this.
Before exploring Pyro Solver, I wanted to mention that around 80% of the audience watching are not subscribed. In our industry, we have a limited audience and your support means a lot. If my tutorials are helping you, please consider subscribing. It's free for you, but it will motivate me immensely to create more content for you. Additionally, if you'd like to support me further, check out my Houdini files and tutorials through the link in the description. These setups are well optimized and easily modifiable to meet your requirements. Thank you for your support. Now let's continue the tutorial.
Awesome. So we have this scene, and let me just play this. So I want to emit smoke from its hammer, and here I'll just recreate everything, and I will share some new techniques as well. So this will be a bit quick. So easiest way to, I can just select this hammer and delete this. And I can use this as a source. So let me just scatter. But we should avoid it. So while working with moving object, we have to plan things better. And here, it's always good idea to freeze this. So it can be any frame. So let me just use start frame. And after that, do the scattering. And after that, you can use this attribute interpolate. So what it will do, it won't work first. It needs these attributes, right? So we need to turn them on over here. So after that, it will just move. So why I'm saying we should scatter on static object, because if it's deforming, then scatter, it will rescatter everything per frame. So that can cause an issue. Cool. And now, so last time we had used Pyro source, but here I will just create this manually. Let's learn this approach as well. So I need density. It can be 1. So I'll just use rasterize. Here I have not mentioned p scale, right? It's always good idea to reduce it by default. Otherwise it can be very heavy. So here I have to select density. Yep, it's visible. Cool. So let me just reduce this. And now I want to check voxel size again, just for. So last time 0.005 we have rendered. Yeah, it will work for this one as well. So we can just go with 0.2. So let's select this one. So this is for density and this is for V. So we can just type V, and we were using less. And let me just compare. Okay, so it's, we need to reduce this overall and here as well. Cool. So after that, let's multiply this with speed also. So let's just use speed and fit 0.1. Let's use length at V 0 to 1. Cool. And we will just multiply with speed. But I want to increase the density overall. So let's just increase. Yep, It's quite visible, and as you can see, it's working. Yeah, awesome. Let me merge these, and our source is ready. So we can just type Pyro Solver, and let's keep everything default and just connect this. And let me see the result. As you can see, it's already started working, and these are similar parameters only what we have already changed. So pixel. So few things I want to share that, so don't try to remember every parameter you see over here, right? So with upgrade and Houdini update and everything, right? So those position will be keep shifting. So best way to learn is always use that DOP network and try to create yourself, that you will have the basic understanding what's happening inside this SOP solver itself, that it is also using this Pyro solver and source technique that we have learned, right? So this is quite quick approach if you want to achieve something really quickly, so that's good. But I would recommend to learn that basic things, just for foundation. Yeah, so I think we can go ahead. So as you know that we need to ground collision, so we can just go close below. Now we have ground collision. And second thing, I can just make changes to the source. I'm not using temperature, burn, and I want to reduce this. So it will push less. Yep, it's working. So next thing I want to do is I want to add noise. So let me use volume velocity. And here also I can to just scatter, volume trail, and I have to specifically select this way. So let me add this skull noise 125, increase it to cool. And again, as you can see on this frame also it's visible, right? So we have to multiply it now. So we will use volume wrangle. So add V multiply by width 01 and density. So these are the like base things we should tweak before playing around with the Pyro Solver. Always work on better source, right? And one more thing also we can do, even we can just add noise as well. Let me just use volume warp, and we have already done this. So just turbulent these, and we multiply, and we have to use fit to properly just put the value. Simplex is best. It's not visible. Yeah, let me hide everything. Yeah, that's fine. Cool. So here you will notice one thing, that it's changing every frame, and I don't want that actually. And will it affect simulation also? Yep, it will affect simulation. Let me just check this. Let me play this. As you can see, it's something is traveling, and how we can fix it? So particle approach will be, we can just use rest position, but how can we store rest position over here? So that also we can do. So that's why I was saying that we should use this static, and something is wrong with viewport. So let me just reset. Yeah, so we have to add rest in here, and with density I will just store rest position as well. So now if you see, we have rest position, and instead of using position, I'll just use bind to read that rest position over here as well. Yep, it's working. I can just change it noise a bit. Yeah, this is better distribution. Cool, that's it. And I can keep this high res. So currently these voxels are not linked, but that's fine. Yep, this is better. So now we knows that how to design source and everything, right? So we can just, in the beginning only, we can make sure that everything is up to the mark. So now we just need to update these things. Cool. So first thing I want to do over here is, let's reduce the voxel size. Yeah, so let's start with disturbance. So we can just add disturbance. Let's increase 10. 10 will be the starting point. Let's just make flipbook. Let's play this. Yep, this is working. So next I will show you how to control this.
Now let's continue with that.
Let's select this, and we have control field over here, and it's reading speed, right? So last time we were using speed. So here we need to calculate the speed over here. So if you don't know that where is this parameter, so I'll just select these, find, hey, where is the speed? So it's here. So use this instead of just, because there are lots of tab and it has multiple parameters. So I'll just I'll turn on the speed and let me simulate this. Right, so it's not adding that much. And what is this compute range is doing? It will just give me maximum range, and that's not useful over here. Okay, so now I want to visualize the velocity. So for that I can just go to field and I can select this speed. I can just open this over here, and I have some options over here that I can just visualize this in 3D. So I can just use plane as well. So this plane is quite useful over here. So I'll just select this plane and I'll just copy this range and paste it over here. And I'm not going to change this over here. I'll just make changes this in this area only. So let me just check which range is working well. So this is fine. Yep, this is working well. So we have to lower this number over here, right? So let me just reduce it, maybe 3. It's not visible. Let me reduce this by 0.7. So something is visible over here. Let me just turn this off and just check the difference. So it's not affecting that much if you see. So for now, let's just turn this off because we don't have enough room for that one. So instead we will use density over here. And I want to turn this to end density, and here also we will follow the same thing. Just range and paste over here. Cool. Let's go to the camera and check. So currently it's adding everywhere. So I want to add in this area only. So I can just go over here and change this. So let me increase this by 1 and 2. So something is visible in the background. Yep. Let me just reset the simulation. Yep. So this thing is working. Awesome. So currently our main plan is we will use more disturbance as well, right? So let's add them. So we will have more speed in the system to deal with. So let's just dive inside. So here I can just use extra disturbance. So I think this is fine and leave it to default. Let me connect these. Reset the simulation. Yeah, so it's affecting. And now let me just check the velocity. Yep, I have some velocity now. Yep, as you can see, it's working. And let me just turn this off. Is there any difference? Yeah, now it's working. So that's what we need, enough speed also in the system. Cool. So now everything. Currently, let me just cross check. We have this. I can increase this over here, but I think everything is working really well over here. So it's not required for now. Okay. It's covering it actually larger area at the moment. So I have to increase this more. Let me use 75 and yeah, I want less area only. Cool. And next I want to reduce this dissipation as well, so which is here. So I can just go and reduce that, which is also fine. So if you notice over here, can you see we have some stepping issue? And what will be the normal approach of this one? We can just use substeps and everything, right? So for this kind of stepping, we don't really need that substeps. And I will just show that. So there are the many reasons of using this static scatter, right? So you will notice the now. So here, why it's creating that stepping issue? So let me just take a screenshot of this. So currently this is current frame and previous frame is this. So here we don't have data in this area. So what substeps will do, if you use two substeps, it will just add one more data in here. And if we use three substeps, then it will add three data in here. But what substeps will do, it will also increase the simulation times 3 times as well. So that's not solution for this kind of issue. So what we can do, we can just fill the gap at source level only. So let me show you how we can do that. So we just need one connectivity. So what it will do, it will just give class, or in some cases it can be a ID. So it's from 0 to 9. So currently we have 1000 points, and I will just use time shift, meaning I want to select this previous frame -1. As you can see, so I'll just merge these two, and to create a bridge between them, I will use add. And here I can just select class, or if it is particle system, then we can use ID. And again I will just use scatter. So don't use this force count. So what's the issue is, if there is a less moment, then also it will just keep this constant count, right? So we need density instead. So this is more easier. Yeah, so let's check. Yep, default is fine. Let's just turn this off. Cool. So where exactly? Here. So if I stay on this frame and if I reset this simulation, it is still showing, right? So what we need to do over here, instead of one frame, we can just use 2 frame as well. So it will create a bit longer trail now, as you can see. And now let's just check. Let's reset the simulation. But we cannot just go that way, right? So for now, technical problem we have fixed, but we can just implement other stuff also to avoid that. So let me just reset the simulation. Yeah, it is there, but if we add collision also over here, then it can fix some issues. So let me add collision. Oops, I have to copy this. And connect this. So here also I have that option. Just go and select VDB and I can just use STF. Awesome. Let me turn everything on and I want to reduce voxel as well. So now you can see it is reduced, but it is not fully fixed. And let me show you other techniques as well, how you can fix it. So currently why it is there, it is because of this noise. Currently we are using this rest field, right? So instead we can just use direct rest position as well, and this tip is really useful. So it's a bit advanced, so we can just use this point cloud open. So this is really useful to transfer the data, and here I just need to select this and input 2. So here I can just transfer data from points to volume, and I have everything in here from velocity to rest as well. So remember, rest is pointed over here. So I'll just use this point cloud filter and I will just type rest and select this over here. As you can see, there is some minor difference. But that minor difference will fix everything. Now let me reset this. Okay. If I reset this simulation, it will be fixed now. Right? And if you're still new to the warp, just take a screenshot of this. This thing is very useful and it will save you many times. Awesome. But if this is still not fixing, then just go with this plan option as well. Yep, everything's working. And yep, we have really nice details in here. So everything is cool. But if I check this, so at the moment this looks bit in this box, right? So maybe we can add some noise where we can get some nice shapes over here. So here we will just use turbulent, and we will need other stuff as well. So last time we have used this damping, which is drag. So always good to start with 0 1, and after that we can just use gas blur. It is too big, so we can just go with 008. Okay. And next we have already disturbance, which is working really well. So to break that, I want to go with, so let's just use which box will be better. Let me increase this cube. Yeah, so around 2 or maybe 2.25. Let's just check. So we can go with 2 or maybe 2.25. Yeah, and I will reduce these, and let's say increase pulse length, and I want overall less strength, so I'll just reduce scale. Awesome, and everything is working really well over here. Let me just reset these, cross check. Let me go with this one now. Yep, let's make a flipbook. Let's play this. Yep, this looks awesome, and there is always room for improvement, right? So I would recommend you can just follow some reference for this and work on better noise, better, you know, how to control things over here. Yep, so next we will render dust interaction, and I will just select this over here, out dust. So here we will use Solaris to render it, and let's just organize this. I don't want to use this. Yeah, everything looks cool, and I want to keep it bit red. Awesome. Here I can just use lob network to use that Solaris, but I can go for this one as well. It's similar only, and currently this is pinned, so let me just, yeah, it will open new viewport, and this is how it looks. And here let me import that. Just go over here, so import, and next I want camera as well, so I'll just import the camera. Let me just play this, so you can see here something is visible. Let me rename this dust, and I want to load that character as well. Let me load, copy this. I want velocity, paste. Yep, so here I can just use Karma, and so it's ready to render now. And I have to make sure that I select this camera, and let's just render this. Yep, so my favorite frame is 60, and I want to screenshot this. So for that I can just use snap. Cool. Next we will work on lighting. So for lighting I will use this as HDRI, and this is really cool website. Cool, so let's use dome light, and I want dark background. Yep, so it's visible over here, and let me just read that. Venice. We can rotate this if you want, but overall this is fine. We can just increase this exposure a bit. Yeah, so this is more bright, and let me add grid as well. So without grid it's not that cool. And let me just increase. Yeah, this is fine, and I have to change color a bit. So I will go with 0.4. At the moment it's using CPU, and let me just snap this out. I want to check rendering speed as well, so let me just turn this off. Let's use full HD only. Cool, let's just render to ambient. Yeah, smoke is not visible, but we will work on the shading later. But at the moment it's taking 52 seconds to render this, and I have other options as well. So if I go here and I want to use this XPU engine default settings over here, let me just run it. How much time will it take without changing any parameters? It's taking 15 seconds only, and it's extreme fast. As you can see, It's really cool. So we will go with XPU and we have to work on this pyro shading. Let's do that next.
Before exploring MaterialX, I wanted to mention that around 80% of the audience watching are not subscribed. In our industry, we have a limited audience and your support means a lot. If my tutorials are helping you, please consider subscribing. It's free for you, but it will motivate me immensely to create more content for you. Additionally, if you'd like to support me further, check out my Houdini files and tutorials through the link in the description. Since you're here watching the last video of this series, as a token of appreciation, I want to give you a 10% discount. Use the coupon code TRUEARTIST. These setups are well optimized and easily modifiable to meet your requirements. Thank you for your support. Now let's continue the tutorial.
So here that we are using XPU, so it will need XPU shaders as well, and we can just use material library, and I can just type XPU Pyro Preview. So this is kind of quick for pyro shading, and let me just rename these dust. And here I have to just type that dust name, and I have to select dust geometry, which is this over here. So nothing is visible, so let me just dive inside and increase this. Yeah, so something is visible over here, and let me just go with 0.2. So I will have to increase this a lot by 20, and I want to change a color bit. Yep, this looks cool, and let me just render this and take a snap of this as well, so we can just compare. So now as you can see, after using XPU Pyro Shader, this time is more reduced. Cool. And in fact, we can just reduce these samples as well. Do we really need? So that's why we have to just go over everything, and we are not using this depth. And we can just use velocity over here. Just that's it. And other options, we can just leave them default. So for more quality, maybe you can just increase this volume limit, but it's fine. Let me just test. So now it's taking 3 frames only, but it's too grainy, and we can just use. So let's just use 64 only for now. Yeah, I want textures on character as well. So for that, I will use MaterialX. Yeah, so I have to use this MaterialX standard surface. Yep. And this is for character, so I'll just assign it to character only. Character. Cool. And I want image over here, so basically texture of that. So it will be MaterialX image. So how do I find out the texture of this one? So it is already there with the geometry itself. So if I go over here and if I dive inside, and as you can see, it's using some SOP already. So I'll just go to this texture, copy this path, back stage, and I'll just paste it over here. It's reading that texture, and 0. I have that texture now, right? That's what I want. And I want to give it some cool color as well over here. So I think let's go with bit bluish. And I want to cover this area also with this, and we can just use smooth also overall for pattern. Cool. Yep, this is working really well. Let me just render this. Snap. And as you can see, we have lost the light. So I think it's because of this we have increased. It's too large. So we need to reduce this size. Yeah. Let me just cross check. Do I have lights? Or is it? Let me pin these and just double cross check. Yeah, this will work, but we need to reduce color bit. Yeah, so this looks more bright now, and let's just test this render. Yeah, this looks better now. And before rendering entire sequence, I want to just check half res, and I want to render odd frames. So at the moment you see 120 frames are there, so it will render 60 frames only. So but it will render one, it won't render second frame, it will render third frame, that way. So it's quick, so we can just cross check everything is working in terms of motion blur and moment and everything, right? And as we will render these in low resolution, so let's just use filter over here, NVIDIA. So it will just denoise everything. Cool. So let's just set this path, render. Cool. Let's check this next. Let's check this render. Oops, everything's blank. So as we have rendered odd frames, so we have to make sure that to use nearest frame, so it won't give that issue. Yep, that grid is not working over here. We will fix that. But overall, we need to fix the ground as well. Yep, rest is good. Okay, cool. Let's just disable everything over here, and we can just use 0.5, 0.5 and 0.5. That's good. Reset, and I want to increase this. And one more thing, I can just use shader for this grid as well. So I want zero specular on the grid. I'll just make changes to the color. Let me reduce this by 0.05. Cool. And we can just reduce this even more. We can reduce this a bit. Yep. Now we have more. And one more thing I would like to say is, if we render this on Mplay, so currently this is half resolution. So we were using this NVIDIA denoiser. So what it does, so it just remove those detailing we are looking for in the dust. When you see, this looks more flat and this is more detailing. So in some cases you can use this denoiser, but for now I don't want to use this. Okay, so let me just use dust over here, version 1. and I can go with full resolution render, full range. Cool. And I want to increase this. Let's keep it default. So default is also good. So other stuff is fine. We don't want to tweak anything. So but remember, this is not the render resolution currently we are following over here. So if I middle click, it's 0.008. So render resolution is 0.005. So let's just use 0.005 and cross check, it is here as well. So should I just cache this and after that render? So I have to wait for that, and here I have option. So I can just select this render, copy this, and if I go to this stage over here, and here I can just use drop network. In drop network I have option to set sequence. Oops, it's not. Am I reading the right node? Let me just copy again and paste it now. So fetch sim, and I will use this to render. So before rendering this, let me just double check if it's properly rendered and we are getting this. Yeah, I know I have this black, right? So maybe in the comp I will just add this similar color so it will be fixed. I can see some grain over here, but that's fine. So we have 20. We can increase density a little bit. So rest is already good. Yeah. So we don't need that much exposure. Let me just double check. So what's the difference? Yeah. So if we reduce the exposure, it's taking lesser time rendering. And just for test, let me just turn on this filter denoiser and let me just check. Is it helping or not? So if it's not helping, then I will disable it. Actually, I need this kind of grainy feel, kind of cool. So it's up to you that you want to use this or not. But in my case, I won't use that. Let's disable this. Okay, so everything looks cool. We will launch this high-res simulation, and after that we will render. So for that we need to just go over here and node by node launch render. Oops, currently it's rendering one frame only, so we have to select this range. So whatever select we over here, it will take the same range in up node as well. So you make sure select everything and double cross check. Yeah, we can see the range. Let's play this. So I have rendered some frames only. The disturbance is too much in this one, right? So we have to reduce that, and let's add hammer smoke as well. And we will render with two different camera also. So let's do that. So I have already merged this file, and now let's reduce this. So let me go to this frame. So currently, okay, this is the simulation, and so in this case we exactly know what is the issue. So this gas disturbance is too much. So if you are not aware that which is causing the issue, just disable everything and start one by one. So in my case I know this, and let me just copy this and paste it over here. So mostly we have to play with the range. Okay, so current, let me just, I want to cover lesser area, so let me increase. Yeah, so it will have less impact, and let's increase this bit. Okay, and next I think I can just 45. That's fine. Okay, so let's just check few frames. Let me reset the simulation. Yeah, that's what we want. Lesser push. Cool. So we will recache this, and again I want to cache this as well. So in here we will have to double check. Okay, so we don't need this temperature flame, so disable this. And here also we have similar options, density and everything, which is fine. And one more thing, avoid this shop material path. So sometimes if you are using mantra, then you won't be able to use the custom shader. Okay, cool. So I prefer this color for the rendering so I can easily identify. And let me copy this here and paste. This is smoke sim version 1. I need to copy this and paste it over here. So now I will have two simulation. One simulation is smoke. Yep, I have to import that smoke also over here. Set smoke. And let me just copy this path and paste it over here. For visualization purpose, let's just turn this off. And we have to assign it color. Okay, let me render. It's again black, so it's a smoke. I want to keep it white, so let me reset this color and we have to reduce it. Okay, reduce it more, little bit. Let me just turn everything on. Yep, this will work. Awesome. And I want to render one more angle from this area as well. So let's just create one more camera. Oops, it's not. Yeah, so let's just stop the render. Yep, this is fine. As I want to render two camera, so this is for the one camera and this will be my second camera. So let me select second camera and I have to read this again over here, which is render smoke. Yes, connect this and we can paste it over here. Yep, everything looks cool. We just need to turn this on. 0.01 for this is fine. We don't need that much detailing. And one more thing, hammer is also missing. So let's add this. Let's copy stage and paste this over. Yep, now we have hammer. Cool. So I think let's launch a render. And we will check this next. Let's check renders. Yep, everything looks cool and we have really nice smoke detailing and dust detailing as well. And interaction is also perfect. And let's check second render. Yeah, this camera angle is also good. Yeah, I will use some denoiser and will add background plate as well. So as an enhancement, we have not used particles. As a next step, you can just check how we can apply particles. So it's always good to use particle source. And one more tip, as we have not followed any reference in this one, right? So I highly recommend to follow some reference. So how you can just follow. So this is really cool website, Action VFX we have. And you can just open any footage you want, just take a screenshot of these. So here you can just place some character, that what is the scale of the character, and based on that you can just walk on the scale, that cube we were changing for the noise and everything. You can just see how breakups we have, how large frequency we have. So based on that you can add disturbance, turbulent and everything. So that will be the next step you can do.
Thank you for following along with this series on Houdini Introduction to Volumes 1 Dust Interaction. I hope you found each part insightful and that you've gained valuable skills for your projects. If you enjoyed this series, please give it a thumbs up, share it with others, and don't forget to subscribe for more tutorials. Your support and feedback mean a lot to me. If you have any questions or suggestions, feel free to leave a comment below. Stay tuned for more exciting Houdini tutorials coming soon. See you next time, and happy learning!